Hello. In this video, we take a look at the water versus ground classification mmWave lab and describe the procedure to download, build, and run the Code Composer Studio project provided with it. We'll start with a brief overview of the water versus ground classification lab, go through the hardware and software requirements, and the process for downloading and building the source code provided with this lab. We then describe how to load and run the program on the EVM and use the associated GUI to get the results. This lab demonstrates the application of TI mmWave sensors to differentiate between water and ground. The fundamental principle being demonstrated is the ability of TI mmWave sensors to detect extremely fine movement of the target using phase measurement. This lab exercise runs on TI's IWR1443 and AWR1443 evaluation modules. The EVM is mounted on a flat surface with the sensor antenna aimed at the container containing water or sand as shown in the image. Ripples in water introduce measurable phase difference in the reflected signal, which can be used to classify water from a solid surface, for example ground. The lab provides full source code and a CCS project. Please ensure that the required software packages as listed here are installed on your Windows PC. Please download and install the latest TI mmWave SDK and all the dependencies listed in the SDK release notes. These are needed to compile the lab source code. The Water vs. Ground lab source and CCS project can be downloaded within CCS using the TI Resource Explorer. You will also need UniFlash to flash firmware images onto the EVM. MATLAB Runtime 9.1 is needed on the Windows PC to run the Water vs. Ground Lab GUI. The lab works on both IWR1443 and AWR1443 EVMs, so you'll need either one of these along with a 5V 5A power supply. Finally, you will need a small, wide plastic container as shown in the setup images. The container should be filled with water or sand for the classification experiment. Let's go through the steps required to download, build, and run the Water vs. Ground classification lab, starting with the prerequisites. It is assumed that you have the latest TI mmWave SDK and all the related dependencies installed on your Windows PC. If not, then please download the latest TI mmWave SDK and follow the release notes to install the SDK and all the required tools as per the version numbers listed in the release notes. A couple of key points to note when installing the SDK. First, please make sure that any old Perl installations are removed from the PC before installing the version of Perl listed in the SDK release notes. The second point relates to downloading the crc.pm Perl module. After you have downloaded and saved crc.pm, locate the saved file in the mentioned directory and remove the .txt extension if it is there. Please ensure that the file has a .pm extension and not a .txt extension at the end. Moving on to the next step, which is to download the lab project. All mmWave lab projects are available in TI Resource Explorer under mmWave Training. To download the Water vs. Ground lab, start CCS 7.1 and select Resource Explorer from the View menu. In the Resource Explorer window, select Software, then mmWave Training and Labs. Under Labs, select the Water vs. Ground Classification Lab. The contents of the lab should be visible in the right side view. Click on the Download and Install button in the top right corner and select the Make Available Offline option. Agree to the license terms to download the lab to your machine. The project will be downloaded in CTI mmWave Training. Once the lab is downloaded onto your machine, select the CCS project and click on the Import to IDE button. This copies the project into the user's workspace and imports it into CCS. Once the project is imported, it should be visible in the CCS Project Explorer view. We have now successfully downloaded and imported the lab project and can move on to the next step, which is to build the project. Select the Water versus Ground Classification project in CCS Project Explorer. Right-click on the project and select Rebuild Project to start building the project. Selecting Rebuild instead of Build ensures that the project is always recompiled. This is especially important in case the previous build failed with errors. It may take a few minutes for the build to complete, and especially the very first build may take longer as the runtime support library needed by the project may get compiled for the first time. The build progress indicator may not get updated during this process. On successful completion of the build, two files should be generated in the project debug directory. These are the .xcr4f and .bin images for the Water vs Ground lab. If there are errors with the build, please ensure that the mmWave SDK and all its dependencies are installed correctly as mentioned in the mmWave SDK release notes. We have now successfully built the lab project. However, before we can run it, we need to prepare the EVM for running the compiled binary from CCS. It is important to understand that there are two ways to execute the compiled code on the EVM, namely the deployment mode and debug mode. In deployment mode, the generated MSS firmware image with the .bin extension is flashed onto the EVM serial flash. On power-up, the stored firmware image is copied from flash into memory and the device starts executing it. The second mode is the debug mode, which we will use in this video. In this mode, the MSS executable with the .xcr4f extension is downloaded and executed from CCS using JTAG. You will need to flash a small CCS debug firmware on the EVM to allow the EVM to connect to CCS. First, power on the EVM and connect it to the PC using the provided micro USB cable. Then, open the Windows Device Manager and you should see two virtual COM ports for the EVM as shown here. Note these port numbers as they will be used later for flashing the firmware image and running the lab. Put the EVM in flashing mode by connecting jumpers on SOP0 and SOP2 headers as shown. Open the UniFlash tool and in the New Configuration section, select the appropriate device depending upon your EVM. Click Start to proceed. In the Program tab, browse and locate the Radar SS and MSS images which are available in the mmWave SDK installation directory as shown here. Open the Settings and Utilities tab and update the COM port number with the application/user UART COM port number noted earlier. Now, return to the Program tab, power cycle the EVM and click on Load Images. If the flashing process completes successfully, UniFlash console should show a success message. Now, power off the board and remove only the SOP2 jumper to put the EVM back in functional mode. Now we'll connect the EVM to CCS and run the lab. To connect the EVM with CCS, we first need to create a target configuration. Open the File menu and select New Target Configuration. Name the target configuration and check the Use Shared Location checkbox. Select Texas Instruments XDS110 USB debug probe in the connection drop-down and select either IWR1443 or AWR1443 device according to your EVM. Save the target configuration to complete this step. Open the View menu and select Target Configurations. Our target configuration should be visible under User-Defined Configurations. Right-click on this configuration and select Launch Selected Configuration. Once the configuration opens up in the debug window, select Texas Instruments X3S110 USB debug probe and press the Connect Target button. With the target connected, click on the Load Program button in the toolbar. In the Load Program dialog, press the Browse Project button and select the lab executable with the .xcr4f extension. Once the program is loaded, press the Run button. The program should start generating console output as shown. You should see the CLI operational message, which indicates that the program is waiting for sensor configuration from the user. The sensor configuration is provided by the lab GUI in the next step. Now we are ready to run the lab GUI, which is downloaded in the lab directory under mmWave training. Locate the GUI executable as shown and execute it. Once the GUI starts, press the Settings button and update the CLI and visualization port numbers with the UART and auxiliary port numbers noted earlier. The name of the default provided configuration is shown in the configuration file name text box. Make sure that the Load Config File checkbox is checked on the GUI window and press Start to load the configuration. You should see the configuration messages being sent in the MATLAB CLI window. Fix the EVM on a desk with the sensor antenna pointing towards ground as shown in the setup images earlier. Fill the wide plastic container with water and keep it directly under the sensor. The GUI should read water on the display. Replace the water in the container with sand and keep it under the sensor. The GUI display should change to ground. Press the Stop button to stop the binary. Please note that once you press Stop, it may not be possible to start the lab again by pressing the Start button. In order to get the lab running again, you may need to shut down and restart the whole setup, which can be done by following these steps in order. First, close the lab GUI. Then disconnect CCS and power cycle the EVM. Next, reconnect the EVM with CCS. Load and run the lab executable again. Then start the lab GUI and update the COM port numbers in GUI settings. Finally, press the Start button on the GUI to start the lab again. This concludes the video overview of the water versus ground classification mmWave lab. To learn more about TI mmWave sensors, please refer to these resources. Thank you.